You type a seemingly impossible request, like write a working simulation, and watch as lines of complex code instantly cascade down the screen. Within seconds, it delivers a product that would take a human team weeks to build. But it is the way the software responds that catches you off guard. It doesn't act like a spreadsheet or a search engine. It behaves unpredictably, like an alien. For decades, artificial intelligence promised sudden breakthroughs but delivered grindingly slow progress. Practical tools advanced by inches, never realizing the dream of a machine that could actually think. This image shows the Mechanical Turk, a 1770 automaton that toured the world, beating figures like Ben Franklin at chess. People desperately wanted to believe the machine was intelligent, but it was a mechanical illusion hiding a human inside its gears. Today's large language models aren't hiding a human inside the cabinet. Within months of release, these systems began passing the bar exam and acing the neurosurgery test. To figure out how to work alongside this technology, we must look beneath the chat interface. We need to understand the structural changes that made this broad capability possible. This evolution suggests that our relationship with the machine is moving toward a co-intelligence. The previous wave of AI arrived in the 2010s, driven by global enterprises looking to build powerful prediction systems. That era relied on a technique called supervised learning. Supervised learning requires humans to label millions of samples. To recognize faces, you tag thousands of photos. The algorithm ingests this, mapping tags to outputs. Organizations used these pipelines to optimize shipping, drive decisions, and generate content recommendations. If you used a voice recognition system or a translation app on your phone during that time, you were interacting with this exact type of supervised machine learning. These systems were efficient at their specific tasks, but they possessed zero general intelligence. They couldn't generate a novel idea if you asked them to. Supervised learning produced highly effective, rigidly narrow machines that were entirely constrained by the data humans fed them. The current explosion in capability happened because researchers abandoned the requirement for labeled data. They shifted to a process called unsupervised pre-training. Instead of tagged datasets, billions of tokens from books and websites flow into an expansive neural network. Without a human to provide answers, the AI independently analyzes the text, recognizing structural patterns and contexts on its own. It tracks these patterns using mathematical weights. Weights are adjustable parameters, the mathematical connections encoding the statistical probability of specific words or parts of words appearing next to each other. The scale is difficult to comprehend. The original ChatGPT contained 175 billion of these individual weights, connecting different concepts. No human programmer sat down and wrote those 175 billion connections. They were derived entirely by the machine reading the training data. By removing human curation and increasing the volume of data, the AI essentially built an immensely detailed statistical map of human language and thought. So how does an expansive network of mathematical weights actually answer a question when you type in a prompt? In autoregressive token prediction, the AI looks at your prompt and generates a probability tree. It uses weights to calculate the single most statistically likely word. Then it repeats that calculation, chaining tokens together to construct sentences in real time. Text generation relies on predicting the next word in a sequence, but visual AI models like Midjourney or DALL-E operate differently. Visual AI uses a process called diffusion, while text uses token prediction. Visual generation starts with completely randomized static. Based on learned text-to-image pairings, the diffusion model sequentially removes visual noise step by step until a clear picture emerges. Whether it is writing code or painting a landscape, there is no thinking happening in the human sense. Beneath the illusion of a conversing intelligence, generative AI is a relentless engine of statistical probability. This creates a paradox. If the system is strictly guessing the next likely word based on math, how is it capable of passing a complex medical exam? The answer lies in a phenomenon called emergence. Emergence occurs when a model develops the ability to perform complex problem-solving that its base programming should not technically allow. When researcher Ethan Mullick asked an AI to show him something numinous, something evoking spiritual awe, it spontaneously wrote a program to generate the swirling fractal patterns of the Mandelbrot set. Asked for something eldritch, it immediately coded a text generator designed to mimic the otherworldly horror style of the author shown here, H.P. Lovecraft. Its immense scale draws connections between disparate concepts. The way it solves problems is often completely inscrutable, even to the engineers who built it. Scaling a simple prediction mechanism creates an unpredictable intelligence, one we must learn to manage rather than command. That token prediction mechanism is also responsible for the system's biggest flaw. Because the AI optimizes strictly for the statistical likelihood of the next word, it has absolutely no internal concept of objective truth. It only wants to produce a coherent text that satisfies your prompt. This leads to hallucinations, completely fabricated lies that sound accurate because they perfectly match the structural patterns of human language. But that exact lack of rigid truth is also the source of the AI's creativity. Because it is just connecting tokens, it can seamlessly synthesize a lava lamp patent, 14th century England, and fast food into a novel business idea without hesitation. This is why your inputs matter. As this diagram illustrates, if you give the AI a short, generic prompt, it will follow the most common statistical pathways in its training data. You will always get generic, average output. To get high-value work, you must provide context and assign a persona. Telling the AI to act as a professor forces it to abandon common patterns. It searches deeper into its weights for specific, relevant connections. Breaking the default statistical pattern is the only way to extract genuinely innovative and original work from the system. To succeed, we must move past the traditional command and control relationship with software and adopt the role of a collaborator with an alien co-intelligence.